which actually works, and you can see there is a gun installed over that, or that is used for applications in the military. Let me share my screen first. Hi guys, this is Samarth Golwalkar. I'll just share and then we can continue. Okay. Okay. Yeah. Oh, okay. Yeah. So my name is Samarth. I am a 2020 pass out from KIIT Bhubaneswar. As you know, it was in COVID batch. So yeah. After that, I started working with the KPIT as a trainee, and subsequently I was promoted to software engineer, then to senior engineer. Now I'm working with Corix, which is an automotive systems middleware company. As a at a designation of senior software engineer. So yeah, so that is my introduction. We'll continue with today's talk. So the topic of today's talk is like AI-powered drones and the electronics behind the autonomous ride. I'll cover a brief introduction of the architecture and how this autonomy, the so-called autonomy, how it is achieved, and what is our current state of affairs and where we are heading. So I'll just move to the next slide. Yeah. So the agenda is to take you guys from a basic understanding of what are drones. Many of you people would be knowing this, but it's my just for an introduction. I'll start with what are drones, what is AI in drones, what makes in drone AI enabled, what are the electronics behind the drone architecture, protocol used, generic protocol used for intra-drone and ground station communications, data flow, how a drone, an autonomous drone takes in a decision, what are the new trends in drone, and what is India's state of affairs. And we will also talk about a recent war or a operation that happened, which had an extensive use of drones. That is Operation Sindhu. Yeah. So after that, we will have a Q&A, and subsequently, I will pass this talk to Ashutosh or Amla. Okay. Yeah. So let's continue. So what are drones? What drones are uncrewed, remotely operated, or remotely autonomous vehicles that operate in air, land, or sea. They perform tasks using electronics, sensor, and navigation system, often supported by AI. Mostly the scenario, there are three domains in which the drones act, that is aerial drones, sea drones, and land drones. There is a thin line between the drones and robotics. I personally, during my time preparing for this presentation, I personally find that the thin line could be the Asimov's law of robotics, because the drone often have to kill the human being. If you are aware with those, that the Asimov's law of robotics actually prohibits like harming any human being. So it does, like the drones doesn't follow those until and unless it is programmed to do so. So yeah, so that is the basic. If you guys would be thinking like if there is a difference between the two, yes, there is. Drones can actually hit targets that actually harm human beings. The types of drones are mainly operate in three main domains, major domains. Those are air domain, marine domain, and terrestrial domain. That you can say air, sea, and land. So yeah, so those are the three things. So first we will cover what are the types of drones that work on the aerial domain or air domain. First is unmanned aerial vehicle. As you have seen, I'll also show an image of what it's actually an unmanned aerial vehicle is, and we will after that. So, and another thing that generally is a terminology used is an unmanned aerial vehicle system. The difference between the two is an aircraft that is controlled remotely or autonomously without a pilot on board is known as unmanned aerial vehicle. The another thing is unmanned aerial system, which consists of the other supporting system which lets this aerial vehicle on in air. That is ground station, communication stack, and the satellite communication through which the drone communicates with the ground stations, and the data link through which it transmits data back to the ground station. So this entire ecosystem is actually called unmanned aerial system. Yeah. So there's another classification that happens in the types of aerial drones, that is autonomous drone or autonomous air drone, that is able to navigate independently, take decisions based on the sensors that are on board with it, such like a lidar and camera and IMU, barometer, and GPS. Upon on that, it can take decisions and work autonomously without any ground support or the signals that are sent from the ground. Second, there is another classification that is based on the rotor classification. You have seen like 4 rotor drones that are known as quadcopters, hexacopters, octocopters. All these drones are defined from point of view like how many rotors are there, and that's why the copters term coming. The number of like the rotors is defined by a term that is quad, hexa, or octo, and the copter like the rotate. Okay. Type there another the another part too is the drones in another domain, that is C domain. Similar to the air domain, these are called uncrewed surface vehicles that operates on water surface, similar to the robotics boats. As I say, robotics boats we can call them, but these sometimes these boats or the vehicles contain weaponry that can harm a human being. So we can not directly take a point of view that these are robots. So next part is uncrewed underwater vehicle, that is autonomous submarines that can operate autonomously without any human interaction. But right now the trend is whenever if you have watched or seen anywhere like on YouTube or something, there is always a cable connected to an autonomous drone that works under the surface, because the communication that has to happen with the ground station for transmitting the data back is it's not still mature. So we are using cables in order to interact with a drone that works under surface. So remotely operated vehicle, that is yeah, the same thing that I have explained, that it is tethered to an optical fiber, it is connected, and it does all its missions accordingly and sends the data back. So another thing is autonomous underwater vehicle. That is actually a complete system that works autonomously under the water surface, which takes a decision automatically without any cable attached to it. And sometimes these are used for the military applications and naval applications as well. So yeah, those are the 3 things. Another part too is what do I call it? Land drones. You have seen robots and for checking the mines, whether the mines are there in the field, to track when there is a earthquake or something. People use drones in order to track where are the casualties, if the people are alive, to search them, track them, so on and so forth. Sometimes for the military point of view, these land drones are attached with guns, which can be controlled by the with their perspective, like with their respective partners. That is another concept of man-machine teaming, which can attack autonomously based on the targets it has been trained on. Yeah, I'll move to the next slide. So if you see, okay, if you see over here, you are seeing 3 types of drones. This is actually a drone used. All 3 are of the military application, and one image is based on the types of drones that are there in the market right now, and the types of designs that are there. The first one is obviously a land drone, which actually works, and you can see there is a gun installed over that, or that is used for applications in the military. The second one is actually a Sagar Defense. This is an actual drone that is created by the Indian company, that is Sagar Defense Engineering. that creates these autonomous boats that actually work from you can say Mumbai port to the end of our country, that is Kerala's some port, and it works autonomously. It tracks, it detects, and obviously you see the guns are also there, so it can also hit. So these are few examples, and if you see over here on the that is written MQ-9B Predator, this is all you all know. This is an unmanned aerial vehicle. That is this is an entire system, the unmanned aerial system that is used by US military for targeting, reconnaissance, and intelligence gathering. And you can say, as there is a weapons bay here, so it can hit you with missiles and all that. So this is actually not an autonomous drone, but a remotely piloted from the command stations, using these satellite communications and data links that actually send back the data from ground stations and back to the drone for efficient communication. The next part to it, I'll continue with the slide again. Just give me a moment. Yeah. Yeah. So move on to the next slide. Yeah. So these are the terms that you should be familiar when you are approaching this domain. The first is uncrewed, like autonomous systems, obviously means that there should not be any there should not be any human aspect on board. Remote or auto control, like it should be controlled via remotely through the ground stations, or AI or pre-programmed autonomy. Like it should be pre-programmed to do certain tasks that it should do seamlessly without any interaction with the human being. Another part too is the sensor, or the how it actually perceives its environment around. That is through cameras, lidars, sonar, GPS, IMU, temperature sensors. So the GPS for the its exact position, sonar it is used by the drones that are used under sea, lidars for the drones that are used on land, cameras and temperature sensors, and barometers for altitude gathering, and understanding where exactly the drone is and perceiving its own environment. Third part is the communication. How like the drone has to communicate and sends the crucial data back to the ground stations, even if it is working autonomously. That happens through the radio frequency. Over here, if you see, I can like this is the white ink I have used, so I guess it is not like it's not visible, but this is RF. This is the long-term evolution, LTE, satellite communication, optical fibers, and SDR. So software-defined radios. So power sources, like it depends on the what kind of drone you are preparing. It is totally based on your use case and requirements, what power source you should choose, and what power source that you should engage on based on the requirement. As you have seen, I have shown in the previous slide, this uses motors that is based on the fossil fuel. This uses battery, and this also uses the aerial or the spirit or the aviation grade fuel in order to run this propeller. So yeah, so that is there. Jets are also being used. This image that is actually at the back of my PPT is actually our own drone that uses that is under production, that uses stages, that uses actually Kaveri engine, dry Kaveri engine, that is a jet engine for its takeoff. So that is also there. It is under production. So just an example to the power sources. So the data processing, onboard microcontrollers and edge modules. If you have heard of NVIDIA's platform like Jetson Nano, Orion, and few more of Google's Coral and tensor processing units that are specific to the application, that are also used on board on the drones, that are that have high processing power but low on processing power is high, but the power consumption is low. That is the voltage it takes in order to process the data, that is very low. So all these things should be under consideration, or these terms should be familiar with you guys when you are approaching this domain. Then I can move on to the next slide. Okay. Now, what is AI in drones? When I say that the AI is there in drones, we are using AI in the drones. What it should be autonomously able to make a decision making, that it should able to identify the path chain. So when I'm talking about the drones, I'm specifically talking about the aerial drones, but the same things could be applied to the naval, as to the surface drones, as well as on the drones that work above the surface and below the surface, both things. So the sensors would be different, how the sensor fuses would be different on based on the domains, but the application and the use case is exactly the same. So yeah, the AI enables drone to make the real-time decisions without any input, such as changing the flight paths, identifying the objects, or avoiding the obstacles, or engaging with the obstacles that are there, if you are talking from a military perspective. Another thing is, how do we detect? So the object detection happens through the onboard cameras and AI models. This is camera is integrated with an AI module, and which actually runs a model. Example is YOLO, that is you look only once, or MobileNet, that is a object recognition model that can recognize people or landmarks or similar thing. If you have to detect a certain during a calamity, you have to detect a certain kind of a thing that your model is trained on. For example, forest fires, that your drone can detect and transmit it back, that this is what is happening over this land area with the location and the coordinates. It can send back. So that happens to the object detection algorithm. Navigation without the GPS. So you have heard, like, there is a term like the GPS being jammed. So when the GPS jams, and our drones enter into such an area where the GPS is like, our drone is not able to catch the GPS signal, or the GPS is banned, or the denied due to some problems in the networks, or due to the enemy. If you are talking about an environment where we are entering into an hostile area and not the enemy territory, so how does our navigation would work? So to to solve that problem, actually, SLAM SLAM algorithms are used, simultaneous localization and mapping, that uses sensor fusion and the data that comes from the cameras, that is fed onto an AI module, that actually crunches that data, and with an onboard fed map of that territory, and localizes that map, and compares the data that comes through the various sensors, such as IMU, temperature sensors, barometer, and altitude sensor, to map its location onto a preloaded map in its memory, based on the data that comes from the cameras and all those things. So this is how the localization or the navigation without GPS works. Smart interaction control, that you have seen, like the drones can now, with the help of this object detection or gesture detection algorithms, that it can detect and understand what its user is trying to communicate with us. With if it can be trained within hand gestures, and hand gestures actually translate to a command, which it would do, then it would actually do that command on which that hand gesture, or any eye gesture or face gesture is mapped on. So that can happen. That actually helps. Here I have given like voice commands and all those things, but it actually happens during. It is very helpful when we are working with the swarm drones, which is a topic we would be discussing. That is a current industry trend. Uh, okay. The next, yeah. Then so yeah. So this is the one. Okay. This is the okay. How drones are AI enabled. So as I said, the drones are AI enabled with the help of majorly one or two things that are added extra on the drones that are not AI enabled. That are, first, onboard edge AI processors. What are edge AI processors? That have the computational power of to compute and live stream of data that is coming in on on based on the data, on based on a model that is that on a model that it was previously trained on. For example, if uh, and after that, what other thing, let us just cover this first, and then we can cover the path, how it acts and how the sensor fuses on the on in a slide when I cover the interaction, like how the data flow works. So yeah, the second layer of this is sensor and perception hardware layer. That the sensors like IMU, barometer, GPS, lidar, sonar, other sensors like infrared sensor, heat seeking sensors, all those things are combined, and the data from those sensors are fed onto this module, where it is crunched on a model that is specific to its needs, or a generic open source model like YOLO or MobileNet, that actually understands like what object, how much it is the distance from the drone, and what it is doing, and what should we work on it. Like that kind of data comes out from the input of all these sensors. Another part to it is the flight controllers and microcontrollers. So these controllers are also fed with the same kind of data, but apart from the camera, camera integration is not done on these flight controllers, but the IMU, heat sensors, IR sensors, and barometers are also integrated with the flight controller to understand at what altitude the drone is working, and that particular data is sent back to the ground stations. So yeah, so there is a robotics middleware over here that is known as robotics operating system. That is a middleware. For example, let's take let's a simple example. If there are two systems, okay, that one works on Linux and one works on Windows, or any other system you can take. For example, some Java-based system is there that is totally different. Its data type structures and all those things are different. How do we integrate this Linux-based system onto this Linux operating system? So there comes the need of a middleware that can integrate multiple operating system or multiple systems onto a single platform for a seamless integration. For example, if data is sent from a system which actually works on a Linux and is received to a system that works on Windows, or a different system that has a different framework altogether, or a custom framework, that can happen with the help of robotics middleware, that is robotics operating system, that can have multiple frameworks on or multiple hardwares on a single platform. That is crucial for the integration. But it is not only a single middleware that is used in the industry. There are custom middlewares that are actually used in order to integrate the multiple systems onto a single drone. Yeah. So SLAM and navigation, I have already, like, this is simultaneous localization and mapping. This is, I have already discussed previously. So it is nothing but navigation without the GPS. So specialized model drones, like VTOL and all those things are specialized model drones. Yeah. We can continue now with the on electronics behind the drone architecture. Okay. So on the left, you see there is an clear architecture on how the drones with and without AGI module work. So what happens? See this on the right, you see the flight controller, GPS, IMU, and other sensors as well are connected to the flight controller, and the flight controller is commanded from the ground station. So it sends GPS, IMU, sends flight controller data, it crunches the data, and it sends the command to the ground station. And the ground station actually again connects and sends the data back, how this is how the drone works. This is I'm talking about the drones, unmanned aerial vehicles, that are the pinnacle of these kind of systems. Another kind of system is the edge AI, where what happens, all this lidar, all this input is actually provided to the edge AI modules. All this data, IMU, GPS data, is provided to this edge AI module, and that crunches the data, and it detects the object, and it sends the commands to what to do now. For if an object is detected, for that object that we were pursuing, that it is detected, and again what should we do. So that command is then transmitted to the flight controller, and then that flight controller actually actuates the other controller. For example, here in the image we are seeing that it is a quadcopter, but it is not necessary that it should be a quadcopter. It could be any kind of drone according to any kind of design, but it should fit our use case. Yeah. So on the right, if you see, is actually an drone architecture that is AI enabled. So if you see how it works, is the AI, IMU, GPS, and all those things are sending data to AI edge module as well as to the flight controller. And flight controller actually, after the command that comes from the edge module, actually sends it to the flight controller what to do based on the input and the GPS based on the input from the all these three sensors. This is just an representative view. You can add more sensors to and attach, and you can do more sensor fusion onto your AI module to get a more actable data that you want according to your use case. Yeah. So next is the communication interfaces. Whatever the inputs that are there on the flight control that is provided by the Edge AI module are actually transmitted back to the ground stations. It is not necessary, but it is just in order to communicate with the drone. And if some changes happen during the flight itself, then the ground station can also transmit the data to the drone in order to like update some mission or something. This is nothing but power management things that flight controller actually takes, like what kind of power, like what kind of source of energy that it should have. Here I have just written the lithium polymer battery, but it could be your sources from the aviation fuel or hydrogen powered batteries, or similar kind of an mixed kind of an power source structure where you can use aviation fuel with the battery according to you. It could be also solar power. So that's the case over here. Yeah. So now I will okay. Yeah. So what kind of protocols are used in order to integrate this intercommunicate, like systems that are inside a drone, for example, Edge AI. So one more example I have not given you. This Edge AI module is nothing but systems like NVIDIA's Jetson, Coral's, Google's Coral, or any application specific integrated circuit that is designed to your use case. For example, if you need some kind 1200 cores that actually that can do parallel processing on different data streams that are coming in, so you, and which would have a very low power consumption, you have to design those. But off the shelves that are there for such an implementation are CUDA cores from NVIDIA, some of the cores, like some of the implementations from AMD, and other from Google as well. There are few tensor processing chips that they use, and that have that high performance, and that can train our model, like that can train our models onto our data. So, and that too on a very minimum power requirement, and they can act like that could be integrated on board. So that's all. Okay. Yeah. So the next part is protocol used for intra and intra-drone and ground station communications. So why this is necessary? So there are multiple systems that do not align with each other unless and until they are designed especially for this particular use case. So the integration has to be there. So how it works? So the multiple protocols such as UART, I2C, serial drone CAN are used, and USB are used in order to interact with the hardware that are not on the same, not from the same system or from the same vendor. So what it does, if you have to connect a flight controller to an AI edge module like Jetson Nano, and a flight controller could be an ARM architecture thing for like STM32 or a NetMel, or from a microcontroller from the Texas Instruments, anything. If they have to be interacted, they could be they could be interfaced with UART, I2C, or USB. These are few examples. There are many more. Like you can have your own like your own custom thing that that can have communicate, like that can be connected with the modules and have a seamless communication. Drone can is also a very good option because of its because of its speed and a consistency. So that could be explored. Another thing is inter-drone communication. Inter-drone communication mainly happens when a one drone is communicating with the other drone. That happens during the swarm or man-machine teaming. That can happen, for example, if there's a squad of 4 drones, that one has the electro-optical sensors and the AI module that is continuously transmitting data to all other 3 drones, which has different which have all these sensors, but AI module is not there, which can take the data from this central drone in order to understand its location in during the GPS denied environments, or if some command or telemetry is received through ground stations for a certain team member of that drone. For example, it's a very common example. The squad of 4 drones. One has a camera and AI module in that. Other has the electronic countermeasures. I'm talking within military perspective. One has attack like some missiles or something. Another one has jamming countermeasures. And yeah. So the from it if one that this the drones that detect an object actually sends the data back all to these drones according to the according based on the these protocols. The communication happens through the Mavlink swarm mode. So their Mavlink protocol is there. This is dedicatedly for the unmanned aerial vehicles. This is another. This is a ROS2 middleware which has its own protocols for communication. This is an MQTT. You would be aware with this IoT, this very commonly used IoT protocol, message queuing and telemetry transport. This is based on the subscribe and publish and subscribe architecture. And then another communication trend, that is drone to ground station, that uses again Mavlink has 2 other modes that is used for telemetry. Another is the UDP, which is a very common protocol, user datagram protocol, that is actually sends the live feed from the drone to the ground stations for analysis purposes and all that. You have seen during the Operation Sindoor, if you have watched any of those press briefings, there they have actually shown how the missiles or the drone was hitting the targets and sending back the data simultaneously. So that happens through one of these protocols. Yeah, so that's from the protocol point of view. Okay. Yeah, this is the data flow, how works it in the AI enabled roles. So what happens, this IMU GPS barometer, actually IMU is nothing but inertial measurement unit. GPS and barometer actually sends the data back to the AI module and as well as to the flight controller for knowing where exactly is the drone is. Second thing is AI module also have an integration with the camera. It could be any camera depending on your use case. Then it crunches the data. So here is the layer, here is the part where the sensor data from all these 3 and 4 sensors are actually crunched onto this AI module. That could be a Jetson Nano, similar powered or a similar low powered GPUs, so that there could be an actable command, that the output could be an actable command that could be transmitted to the flight controller, on which that flight controller acts and sends the signals to the actuators to perform something. For example, the PWM signal is very high or low. If some object is detected, and fins have to be diverted so that you could understand like on which way the drone should move in order to avoid the object. If there is another actuator, if the missile is onto that drone or any weaponry is onto that drone, if we have to engage that target, at what distance that target is, that entire thing is actually crunched onto this AI module that is sent to this controller, which acts upon. So It actually this AI, if you can have in basic understanding, is like AI module thinks what to do, and flight controller does the how part. How to do it is handled by flight controller, and what to do is handled by AI module. So this is how the entire system works. So this actuation, then the flight controller sends the signals to do the to do the needed according to the command, and then the communication systems again sends that the information back to the ground stations, or any ground the anything has to be received back to the drone, then it is received through the flight controller. Or it could be, I have like interfaced it with the flight controller, but it can also be interfaced with the AI module, so that if an additional command is there, then it could be crunched along with the sensor field, like the with all the data that comes in into this AI module. So if you are seeing that the IMU, GPS, and barometer are also interfaced with the flight controller, that is for the its own to know where exactly is the drone, and it sends that data back to the ground station. So that is the thing. So that is how the layering works. The base layer is the sensor layer, the above layer is the sensor fusion layer, and above that is the actuation layer. So you can think of a drone like the actuation works at the top, below is all the processing, and below is the perception. So yeah. Uh, yeah. Now, what are the new trends? So the swarm drones are the new trends you have seen. Uh, if you have seen during the 26th January celebrations or 15th August celebration, there's always a some kind of drone show that is happening. That is actually a swarm, and that has civilian as well as military applications. That it happens. That is the new trend. Beyond visual range, no need for optical fiber. That means right now, few of the drones for effective communication without them being hackable is actually done through optical fiber, but it is not, as you know, optical fiber. The drone has to be attached within fiber or a cable. That is not very efficient. So as the communication become more secure, the beyond visual range drones are possible. Even now they are possible, but these are prone to hacking and electro, like the if you are sending in high frequency bursts to those drones, it could fry their electronics, and then and the like the it would have an impact, like the drone would fall off the like from the air, or it would not reach the target at it was determined to. Micro drones, these are very small drones, sometimes even smaller than your nails, even smaller, sometimes very smaller. Uh, what do I say? Even then, when you cut your nails, even smaller than that. So there's a lot of research going on this topic, micro drones. It is actually, these drones are actually used for maintenance for aircraft planes, or during the when there is there's an calamity like tsunami or earthquake. Similar at that time, for the rescue operations, it could be done. It could be yeah. So another part of this is man-machine teaming. If you have heard about KIIT SOEE program, that's to connect with the airplane with the multiple drones, which would contain the which could independently do the operations. So that is known as man-machine teaming. Second is if as the communication communication is more secure and much better, then the drone with the quantum communication, which can work on the GPS denied environments, could be there. And fully autonomous drone, that once you have actually assigned a task to a drone, then it works and acts automatically in order to complete that task, and whatever the changes that it has to make, it does. So that is the case for the uh, this fully autonomous. Yeah. So okay. Okay. So what is the India's state of affairs in the drone autonomy? I will talk briefly about the what where we are. We have actually designed Swift stealth wing flying test bed precursor to the autonomous UCAVs. This is actually the image that you have showing you in my slide is actually Swift. This is the platform that we have created. It is a stealth wing drone This is a prototype that was created. Now it is under the fabrication, and it would be powered through a dry Kaveri engine, which actually produces thrust of around 48 to 50 Newton meters. Yeah, so that is there. Then there is Rustam 2, that is our male drone. That is actually under the research only. We have not integrated it under the in our armed forces. Second is Abhyas drone. If you have seen that these are used for target practices. Another thing that were used currently in the conflict, in the Sindoor conflict, was this Harop long-range loitering ammunition. That is a joint venture between Israel's IAI systems and Adani Defense. These Harop were used in order to hit the air, to do the air seed, to do the air sanitation operations, where you see that the drone is hovering around a target, and when it finds that target, it actually hits that. So that is in Harop long range loitering ammunition. That is actually done for seed operations. You can search for what are seed operations, and you would understand why these are used, and how we have hit them. There are a lot of videos on internet. You can actually see them and how these Harop has worked, and they have worked fantastic. Another thing is Nagastra 1. This is also a drone that is produced indigenously. That is also a loitering ammunition, but that is completely indigenous. Entire thing, end to end, sensors to onboard electronics, is actually made by Solar Defense. I mean, integrated by Solar Defense, made by many small manufacturers. So yeah, here are we, and there are many other platforms. So I talked about the Patch Warrior program, so that is also there. And like, if you are interested in that, you can go to this Hall's website. You would get everything related to this Patch Warrior program. It is only based on the man-machine team. Yeah. So what is the opportunities for us as engineers? So the opportunities are defense manufacturing. Obviously, I have talked a lot about defense and current like during the current conflict that drones helped us. Payload development. So payload are very important, but drone itself is not a thing. It contains a certain equipment, which, for example, some drones can contain weaponry, some drones can contain sensors, some drones can contain electronic countermeasures, some drone can contain in the case of agriculture, it could contain sprayers and pesticides in order for spraying onto the agriculture fields. Some drones could contain like the some high resolution cameras and edge modules, so that we can get an understanding if a dam is prepared, then what is the level of slit or the mud that is actually at the base level of the dam. All those things could be a solution which could be performed through drones. And another thing is last mile delivery. You have heard that the drones would be sending, like some Amazon or some other many e-commerce websites have tested, like how we would send medicines or our packages through drones, and that is the future trends, and it would be like this is where the industry is going. Another thing is, what are the main things that we should take it from this? The AI will change how we are pursuing the drone development, and AI would be the edge AI modules, or like Jetson Nano and ASICs that can run hard AI models will be a part of the development. Core technologies are sensors, control, and swarm technology that use multiple protocols like Mavlink and all those. ROS2 robotic operating systems for multiple architectures to work on to integrate them seamlessly. And the sensor fusion. Sensor fusion is of multiple types. How you can read about it. There is a huge potential to create a dedicated edge models that can crunch a large amount of data depending on the use cases. So in the small scale hardware like Jetson Nano and Orion. So yeah, so this is something. We are at the end of the talk now. So I'll just give a shout out to TechBairn team for arranging this great innovative event and giving me a chance to speak about it. You can talk with Ashutosh or the present like the organizer in your at KIIT to join one of these courses and get a more in-depth understanding of how the AI models work and how do you actually integrate a model onto a drone, all those things. I would now open this talk for an Q&A. If you guys have any, please go ahead and.
So yeah, guys, Asutosh here. So thank you so much, Samarth, for the great presentation. So I was there in the call, and I was not that much aware about the drone, but I got to know a lot of information. So thank you so much for the great presentation. So guys, we are now open for the Q&A session. So if you are having any queries, any doubt, anything, you can put in the chat, or you can open up your mic and ask the question. In chat already we are having one question somewhere that I will pick it up. So Durlabh Biswas is asking, how is SLAM constructing the map through the inputs? How does it actually visualize the map?
Okay, so what happens? There are many methods within the SLAM. There are multiple algorithms. Okay, I can give you an example. What are those algorithms actually? Okay, so just a minute. Yes.
Meanwhile, guys, if you have any question, please put in the chat. We try to explore some out of the box topic. We try to explore the drone, as you have seen how drone was the buzzword when we were having Indo-Pakistan war was going on, Operation Sindoor. We have used a lot of drone. Most of the drone were built from India itself. Okay, so we are also becoming one of the manufacturer of drone, one of the powerhouses of the drone, and a lot of job opportunities also there in this drone segment and all, because a lot of technology is involved here. So yeah.
Okay. So see what happens. It takes the inputs from the perception layer. So what is the perception layer here? I am inertial measurement unit in order to get the raw pitch and other details related to the what drone is actually doing. Then the camera actually gives an input and gives the visual presentation about the surrounding. LiDAR and flight controllers actually again map and reinforce its understanding of the surroundings, and barometer gives the understanding of the altitude based on the air pressure. Then what happens, it is all crunched onto an AI module, and it is actually checked and actually compared onto a pre-installed map onto this AI module itself. So it compares the generated path with the predefined loaded map onto its own systems, and then according to that it takes the inference that my drone is on this location according to the map. So this is how it actually creates it.
Okay, I guess Durlabh has got his answer. So if you have anything, Durlabh, you can again ask, or you can open up your mic also if you have something.
Yes, I understand. Thank you so much, sir.
Yeah, thanks, Durlabh. We have more couple of questions, like from Isan Saxena. Isan is asking, can we replace CCTV camera with surveillance drones?
Surveillance, actually, see, CCTV cameras are of a different kind. Here you are on an, for example, if we are talking about an aerial platform, then you are at a high altitude. So the high resolution camera that can zoom in could be used. But for your project, if you are planning it to do for a project, and if you can integrate a CCTV camera, that's well and good. But if you're talking about a real military or this application, then you should choose a much better camera that has a much better resolution and works on a much lower power. So that's it is up to you. Like if your use case permits, then you can definitely use. Hatra Roy has some. Ishan,
Yeah,
if you have like.
Isan,
Does that answer your question, or is it like there's some counter?
Or still, if you have any queries, you can unmute yourself and ask. We will be moving ahead.
Sir, thank you, sir.
Yeah, thanks,
Okay.
Ishan. Moving ahead, we have a question from Suhata Roy. She's asking, do the radar system fall under the category of aerial drones?
See, LiDAR is not necessarily under the category of aerial drones, but generally, we have so radars. Actually, radars are used. That is not the case, but radars actually use a lot of power. That if you know, they require a lot of power. Due to if you guys are, if you would be reading this in your fourth year, that radars take a huge amount of power to generate the flower, that radiation flower. Like it looks like a lotus radiation beam that actually uh, uh, detects an object that is very far. So yes, some of the drones like MQ-9 and all those things actually have a very powerful radar installed on it. So it depends like what is your use case, and you can install the sensors accordingly. But if you are working on a very small project that doesn't have such kind of a power source, then where would you install your radar? But yeah, definitely radars are used in the aerial drones for understanding and perceiving its environment. Yes. Does that answer your question, Suhatra?
Yes, sir. Yes, sir. Thank you, sir.
Is that the same thing that you were asking, like related to the radar?
Yes, sir. I just wanted to know is the radar systems um, really for a kind? Are these systems are a type of aerial drones or no?
No, no, these are not aerial drone systems. Actually, these are independent systems that are integrated with the drones for object detection, to detect an adversary that is around 400 200 kilometers away. But that is strictly related to the that from the military point of view I'm speaking, because the jet engines and drones have only one difference, that the jet engines do not actually have a man inside them, and the drones do not, like the from that perspective I'm talking. The drones will contain everything that jet engines have, like from that kind of from unmanned aerial vehicle that is used for military, and it will have all the things, but it would not have a man inside it that would be dictating it. It could be that there could be a ground station, but the radars, data links, electro-optical sensors, missiles, everything, and jet engines, everything would be there in a drone of that kind. So if you want to know more about it, please do go and search what is the CATS Warrior program. It is a very good program for the Indian Air Force, which actually focuses on this. That has a man-machine teaming, and you would get everything from every sensor over there is there integrated with that system. Another company is Adronil. You can search on that. Another company is Boeing that is actually working on these programs. Like not India, but in the United States. And I don't know about Chinese companies, but these are few of the major companies in the West. Yeah.
Okay,
Another
sir.
question
Thank you,
is
sir.
from, yeah, okay, Swatra, thanks. From Piyush Kumar Sharma, what is your point of view on the recent developments of the China's mosquito drone? They have actually, I would not say, and I would not sugarcoat this, but they actually have a very mature drone program, and the micro drones I was working on about, right? It falls under the same category, and I have not seen any Indian company actually work on it. So that's the case. Uh, so
We have another question from Sandeepa. So, is the question, can the drones fully replace air refueling plane tankers in the future? Yeah, this is a good question.
So, okay, so see, air refueling in the tankers or in the airplanes requires an extreme precision. Okay, that if you have seen any videos, that the knob that actually attach, if you have seen Indian Air Forces refueling, air to air refueling, that there is actually a umbrella kind of a thing that actually attaches to this refueler, to the fuel injector, and then it refuels. So in order to, it is, I'm not saying it's not possible, people will work on it, and during the conflict it could be an advantage, because you would not have to send men, in a zone which is highly difficult to enter and refuel the systems and have a loss of life. So it could be a game changer. But right now, I have not seen any military doing that. It is not possible, obviously, for the civilian purposes. But this use case specifically for the military and aviation purposes could be there in the future. I don't know whether some people would be working on it. Yeah.
Okay, so I hope Sandeepa you have got the answer. Still, if any queries or anything is there, you can open up your mic and clear that, or you can also confirm us if the doubt is clear to you. So guys, if any other question is there, please do let us know. We are here to clear your all queries and all.
Priyanshu, I think I have given your answer related to the mosquito drones. There are no Indian companies right now. In the future, we will see some kind of a joint venture or something, but right now I am not seeing any companies or the indigenous research based on those drones. But in the MIT and in the China, they have, like, in Chinese universities I don't know about, but the MITs definitely have this micro robotics lab, which has actually created multiple types of drones, like micro drones. So if you can go and watch it on. They have that on their YouTube channel. Yeah.
Perfect. Thanks Priyanshu for the question. So guys, let us know if any further question is there. So I guess Siraj Ali sir is also there. He had joined. So thank you so much, sir, for joining and taking up your time to be there. So I hope many of you are aware with Siraj Ali sir. He is the dean and professor at KIIT School of Electronics Engineering, dean of
No, it's not Dean.
KIIT
Let
SOE.
me introduce.
Yes.
I'm Associate Dean in Training and Placement in school level.
Yes, sir. Sorry. Yeah, please
No
go ahead.
problem. No problem. Continue. Yeah.
Yeah, so sir has helped us a lot in organizing all these events. So he was one of the catalysts in helping us in organizing this event in collaboration with KIIT School of Electronics Engineering. So sir, if you have anything to share with the students, please guide us.
Yeah, actually, we want to see some of the interested student so that we can immediately start some of our engagement with you. So, dear students, be the part of the TechBairn because they have a bigger plan. This is the small starting. So, keep your interest and try to be associated with the TechBairn. I think you have some engagement plan.
Yes, sir. We have the engagement plan. We have. We will, after this session, we will explain to all the students, sir, and we'll take up their expression of interest also.
Sure.
Yeah. Thank you so much, sir.
Please continue.
Yeah. So, guys, if you have any further question, please let us know. I guess we have got many questions. A lot of people have asked many questions, and there's drone technology and all are in lot more buzzword from the last a few months because of this Operation Sindoor and all the Indo-Pak war plus all the global war that is happening around the globe, right? So please let us know if you are having any further question, or else we can close the session also. We will waiting for 2 more minutes to take up your question. After that, we will be closing the session. Any further question from anyone? So let's see if either you can put in the chat or you can open up your mic and ask the question, guys. I don't think so. We are having any question already. A lot of people have asked the question. Durla, Visan, Suharta, Priyanshu, and Sandeepa. So thank you so much for your question, and I hope we have answered your question. And thank you so much, guys, for joining with us and connecting with us. Hope this session was fruitful and will add some credibility to your career path, career trajectory, and can help you in understanding how the drone works, how the AI is enabled in the drone. And thank you so much, Samarth, for accepting our invite to be here, to be the part of this event, and to guide all the students. So thank you so much, and thank you so much for taking up your time on weekend. Okay, so yeah, thanks, Samarth. So guys, yeah.
Pleasure.
So I will share your LinkedIn profile in the chat, Samarth. So at any point of time, if they will be having any kind of queries or anything, they can reach out to you also. So let me
Sure.
just get your LinkedIn profile. I will share with them in the chat as well as in the WhatsApp group, so that they can connect with you. And if they need any kind of guidance, any kind of anything in the future, they can reach out to you. And as I explain, uh, uh, as Samarth was telling in the start, that he is also passed out from KIIT University. So he is also your senior. He is also from your college. So you can reach out to him as a senior. He will be helping you in if you are having any kind of queries. Let
Sure.
me
Do reach out to me.
Yeah, I'm just sharing your profile to them. So I've shared his LinkedIn profile. You guys can connect with him over the LinkedIn, and in future also, if anything is there, you can reach out to. Okay. Thanks. So guys, uh, I need to explain you few things because we are organizing all this session under the banner of our initiative that we have planned in collaboration with KIIT School of Electronics Engineering. So actually, we are planning to have a lab in the KIIT University. So I will be just explaining you everything regarding that. So, and if you guys are interested, they will be circulating one expression of interest form to you. So you guys can fill up the form and can be the part of this lab that we are planning. And after that, in the end of the session, we will be circulating the attendance form. So that is mandatory for you to fill to receive the certification. If you will not fill that attendance form, you will not receive the certification or certificate of participation of this event. Okay. So let me just share my screen once. I will not take more than 5 minutes. Okay. So I already you guys are here in this meeting from last one an hour. So I will not bore you. So basically, if you can see the screen, we are planning to have Industry 4.0 and Automation Lab in KIIT School of Electronics Engineering, and where we will be building a community of students who will be working in the different kind of projects related to the Industry 4.0 and the automation. Okay, we will be building the different kind of prototype. We will be building the different kind of project where you will be guided by the your professors, your faculty coordinator, plus people from the uh, industry who have 5 years or 10 years of experience. Will be working as a mentor. So you will be getting mentorship from industry expert, one-on-one guidance from professionals who are already in this field and will help you in building the product related to Industry 4.0, different sectors of Industry 4.0 like agriculture, healthcare, smart cities, and all. Okay. Plus, if you, being the part of this lab, you will be having a lot of different talks apart from the learning curve that you will be having, the product, the product and the project that you will working with the like-minded people. Okay, the same kind of people. Apart from that, a lot of different kind of opportunity you will be getting, like the internship plus job opportunities with TechBairn, as well as with our different kind of portfolio companies that we are having, or the hiring partners that we are having. So if you are If you are really interested in working, in doing innovation, in building some product, and you can join us. We are planning to start it from the August. So uh, uh, we will be circulating the expression of interest. We will be also dropping a mail to you with all the details, so you can fill up the form over there, and then we will be moving to the different kind of process that we are having if you want to join the lab. So if you are having any questions, guys, related to this lab, you can ask me. I will be there. Okay. And I will be circulating the attendance link with you also in the chat. So please fill up this form to receive the certificate of participation from our end. I have put in the chat, so please fill it so that you will be getting a certificate of participation. Meanwhile, if you guys are having any queries related to the lab, I'm here. You can ask the question. Meanwhile, in the group also, your WhatsApp group, I'm there. So if you are having any queries, you can put your queries over there, and by within an hour or two, we will be sending you all the details regarding the lab, where you can we will be giving you a form where you need to fill with all the basic details plus the kind of expertise that you are having. Do you know embedded system? Do you know Arduino? Do you know little bit of microprocessor, microcontroller? So all these basic details we will be asking. Okay. For the screening purpose, we will be asking the very basic details that you need to fill over there. Okay, understood? Any queries anyone is having, please do let me know. And the attendance link I have already provided in the chat. So please fill that form. Perfect. You can thank you so much, Akash, for the appreciation. So the link is there. You can also copy to the clipboard. It will be active till 2:30. After that, we will be not accepting the response. So you can, yeah, thanks, Akash. You can copy it and can fill it after this event also. Okay. So thank you so much, guys, for the great audience. I hope it was a great session for you, and we will be organizing this kind of event in the future also. So please be in touch with us. We will be our social media handles and everything. So you can follow us on the different social media handles and everywhere. So thank you so much, Akash.
So the lab would be like a type of paid course or
No. It will be completely free of cost. Nothing you need to pay. No fee you need to pay. It will be completely free of cost. Priyansu.
thank you, sir.
Yeah, thanks. Yeah. So thank you so much, guys. Thank you so much, Israj sir, for connecting with us. And thank you so much for providing the opportunity to us to organize such kind of event. And thank you so much, Samarth, for having with us and giving a great presentation and the insightful insights of related to the drones and everything. Thank you so much. Thank you so much, guys, for this. And I guess we can close the session. If anything is there, you are already there in the WhatsApp group. Please do ask the queries over there. So thank you so much, Suharta. Thank you so much. It means a lot for us so that we can, it motivates us to organize this kind of event more and more. Thank you so much. Thanks. You guys can start dropping. We will be closing the session. Thank you so much.